Hello, all of you. Welcome to another session on logical reasoning. So, till now, we had a decent idea about logical reasoning. So, we'll take a step ahead. The idea of life is to take a step ahead until we reach a step from where we can see the entire transformation, and that's primarily the idea we are working on today when we are talking of logical reasoning. If you have if you're able to see this presentation, right, on logical reasoning, I'm sure, right, you guys have definitely enjoyed the last few questions that we had done, right, on the previous sheets. Few at a level of cat, few probably, a level lower than cat, but all in all, building a thought process on LR and data interpretation, logical reasoning and data interpretation. And like I always say, right, logical reasoning is the Achilles heel for many students. Last year's CAT paper, several students who were good in, not even good in math, ended up doing good in math, but they probably had issues, right, with logical reasoning, or they just could not make it happen in logical reasoning. People who were not so good in English performed good in English, but still they did not perform in logical reasoning. Let's not make it happen this time. I'm sure you guys are with me. We're going to make it happen. We're going to make logical reasoning the place where we can score really high. And the best thing about logical reasoning is all you need to do in the exam, all you need to do if the paper is tough, and I assume that you want a tough paper. Even if you score a 45, even if you score a 45 in the paper, or 45, I'm saying that's how less the score we're talking about. Even if you score a 45 in the paper, right, what will happen is you'll end up scoring something as high as a 99 or 99.5 percentile. That's how good logical reasoning is, right? So, keeping that in mind, I will start off today's session. Of course, since we are talking of a session, we are going to look at questions, right? We're going to look at questions, and we're going to do questions, and that's exactly the point of the class, right? We're going to keep doing questions. So give me a minute while I just check things here, right? Give me a minute. Give me a minute here. That's a lot of questions that you can already see. Right, that's a lot of questions. That's okay. Okay, think it's fine. Okay. Mhm. Okay, let me just check with this while I set it up. Right, while I set it up while I set it up. Mm. Okay. Okay, so that's set up. That's cool. That's good information. Right. That took some time for a non-techie guy like me. That's the best thing that can happen, right? So let's start with a happy note, right? So we are tech enabled, right? We're tech enabled, right? Okay. So good for a technically challenged person. Yeah, so let's begin. Let's begin on a little more positive note. Let's begin on a positive note, right? Okay, so yeah, logical reasoning that we're talking about. Let's start with the first question, right? That's pretty important. This question for me is a very important question. You'll understand why I mean to say this question is important. I want you to take about probably 30 seconds to read on the question, and I'll give you some time to again solve it later. But read up on the question, take possibly 30 seconds, then I'm going to tell you some information on this question and again redo it. First of all, you get an idea, right? The 30 seconds, right? So 30 seconds, okay, good. So I hope you guys have read. You guys would have read the case, right? If you have, that's superb, right? Let's move to the question in hand. That's exactly what we should be doing, right? So let me able to see, right? Are all of you able to see the data? Hmm. Right. Okay. All right. Okay. Let's identify. Let's identify with the question again. So what's the question? The question is this. So there are these rings. Okay. There are these rings. Simple question. Okay. Simple question. Right. There are these rings, and there are these rings. There are 23 of them. That's what it means. 23 rings. Any number of rings. You can take any number of rings from 1 to 23. Someone might ask you, okay, how to get 12 rings, how to get 7 rings, how to get 5 rings, how to get any number of rings from 1 to 20. That's the aim. That's the aim of the question. It's a simple question to start with, right? So to process the question, to process the information in the question, let me be frank with you. That's a nice question, but to process this information, we'll move to another question, right? That's more likely what I would like to do. Like I said, I always want to build a thought process, right? If we can build a thought process, I think we're doing good, right? If we can build a thought process, right? So the thought process is starting with a question like this. But in fact, to build a thought process for this question, again, you have this question right in front of you, right? You have this question right in front of you. To build a thought process for this, to build a thought process for this, I want to give you a question from the top of my head, right? You want to do 198 rupees is able to figure out from this particular thing, right? That is something that's something that we are looking at in this question. Okay, 1 to 198 rupees he's able to figure out. Okay, so are we okay? Does anyone know what is the highest number of coins that can be there in a bag? What is the highest number of coins that can be there in a bag? Let's just ask you this question. Let's just ask you this question. Okay, what is the highest number of coins in a bag? What is the highest number of coins in a bag? Okay, but to start with this question, this is not what I want you to do. I want you to start thinking. When I want you to start thinking, we'll start with another question. I want you to start with another question. The question is this: there are 80 marbles. There are 80 marbles. And out of these 80 marbles, all are of the same weight, except one, which is heavier, right? One marble is heavier. There are 80 marbles, all are of the same weight. Just one is heavier, right? The 79 of them are same weight, one is heavier, right? That's what it means, right? So we have a two-pan balance. You guys understand what's a two-pan balance, right? Has any one of you gone to a vegetable shop and explored what's a two-pan balance? Or all of you order vegetables through big basket possibly, right? Okay, so in any case, this is how a two-pan balance looks. And the question is, what is the minimum number of weighings? What is the least number of times you'd use the two-pan balance to find out which pan is heavier? Guys, please understand the weight of a marble is not known. The weight of one marble is not known. It is just known that you have 80 marbles, 79 are of the same weight, and one is heavier, right? So you got to use the two-pan balance to find out which one is heavier. The principle of a two-pan balance, whichever side is heavier, that side will go down. You don't have any weights. You don't have like 10 gram, 20 gram, 30 gram weights. All you have is this two-pan balance, and you have 80 marbles. You got to surely identify which is the heavier marble. Pretty simple, okay? Pretty simple concept. Just think, right? Most of the people will tell answer is 1, right? Is that right answer? Yes. By astrology, it is right. You cannot find an answer like 1 that is picking the right spot. That's called luck. That's called probabilistic answer. It's not really an answer in mathematics. But if you're looking at a question like this, right, we're trying to identify with the minimum number of weighings to get the heavier marble. How do we work? We work with a process. You'll notice many a times in whatever I do in the classes, right, the online sessions that I do, I will drive in some particular tools. One such tool is MI, that is mathematical induction. There are 5 ways to prove things in mathematics. One is mathematical induction, we have bijection, we have negation, right? So but then today we'll be working on MI. What we'll do is we'll identify with the number of marbles and the number of weighings required to identify the heavier one, right? So we'll choose marbles and the weighings required. Let's begin. So we'll make a rule of thumb that every time one marble is definitely heavy. That means out of 2 marbles, one is heavy. Out of 3 marbles, one is heavy. Right? Out of 4 marbles, one is heavy. Out of 9, one is heavy. Out of 80, one is heavy. Out of 75, one is heavy. Out of 50, one is heavy. Out of 240, one is heavy. The number of weighings we require. Right? So come to think of it. If we have one marble, how many times are you going to use the pan balance? Right now, isn't it a universal truth that there is one marble and that one marble is heavy? So how many times do you think you'll use the balance? Certainly you'll not use it. It is 0 times, right? There's this one marble and I know that is heavy. Why will we ever use the balance? We'll ignore the balance. That's not required for us, right? What we need to know is we need to identify with the fact, not with the marble. What if there is 2 marble? What if there is 2 marble? And one is heavy. Let's say these are the 2 marbles, right? One is called marble A and one is called marble B. The principle of the pan balance is simple. If you place 2 objects, one on each pan, right? And if the weights of the 2 objects are similar, they will balance each other. However, if one of the side is heavy, assuming marble A is heavy, and marble A is placed in the first pan, if marble A is placed in the first pan and marble B is placed in the second pan, what will eventually happen if A is heavier, right? The left side would be going down. And if B is heavier, the right side would be going down, right? That's pretty simple data, right? So we have these 2 marbles, let's say 1 and 2, that's marble A and marble B. Whichever side is heavier, that side will go down. If they're same weight, they will balance each other, right? That's also something we must identify with. If they're the same weight, they will necessarily balance each other, right? Same weight or different weights, right? So let's see what happens. Now let's say this. You choose, okay? You choose whether A is heavier or B is heavier. Now you decide. And now you ask yourself. You placed A on the left pan and B on the right pan. If the left pan is gone down, can't you see that A is heavier? If the right side is gone down, that means B would be heavier, right? As you put in the left pan, one weighing, you would be able to identify in one weighing, you would be able to identify the heavier marble. Even for 2. Let's say for 3. Now what should be the logic for 3? That's interesting. Now the thing once you start increasing the numbers, it'll get more and more interesting, right? For 3. So let's say there are 3 marbles, A, B, and C, right? Now you guys decide, okay? Each one of you can decide which is the heavier marble. Okay, now I'm giving you the choice and saying choose the heavier marble. Don't tell me which one is going down or which marble is heavier or light. All you have to do is place marble A in the left pan, marble B in the right pan. Now let me tell you before you if you before you answer anything. If A and B are of the same weight, they will balance each other. If A is heavier, left side will go down. If B is heavier, right side will go down. Right, so let's check the result. Let's check how many times will we see. We're now ignoring C. We don't know what's happening. So case 1, we have a case 1. Let's assume that left pan went down. Left pan went down. That means A is the heavier. Case 2. Let's say right pan went down. That means B is heavier. Case 3. Let's say both the pans balanced each other. Right? That automatically means C is heavier. Right? But how many times did we use the balance? Only once. Good. That is the minimum number of times, right? We can use the balance to be sure. See, guys, we should be sure here, right? It's not just about some random guesswork. But let's take 4. Let's take 4, right? If we take 4 marbles, is it that we can still do it with one wing? That's exactly what we want to find out. But are we clear on this? How you take A and B, A on one pan, B on another pan? If it balances, C is the heavier. If A goes down, A is heavier. If B goes down, B is heavier. That's as simple. So let's place the 4th marble and see what the result gives us. So we'll take the 4 marbles. Let's call them A, B, C, and D. So that's 1, 1, 1, and 1. So first case, we'll take, we could do 2 things. We can take 2 marbles and place it in each pan, or we can take 1 marble and place it in each pan. So let's say I take A and place it in the left pan and B and place it in the right pan. Let's say A went down, case 1, right? Left side went down, so A is heavier. Case 2, let's say right side went down, right? That we're still stuck between C and D. That means to be sure, again we'll have to use, that means to be sure, you need how many wings? You need 2 wings for 4. Likewise, if you try for 5, and what we can do from 5 is we can split into two groups. That is, I can put 2 marbles here and 2 marbles here and verify it instead of taking one at a time, right? For 6, we can do the same thing. For 7, right? Again, we could do the same thing. For 8, we could do the same thing, right? We can split it into 2 parts. For 9, and that's a beautiful part, probably at a level which should probably, be a type of question that you should start thinking. And guys, let me be frank with you, right? Folks and friends, let me be super frank with you. These are the type of questions which even may come in the interview stage, right? Because not everyone believes during the interviews, right? At least the panelists don't believe that just marks is enough. Probably they want you to answer some questions face to face to understand whether you really have the logical thinking and even the aptitude of and quant that you probably work with in the examination, right? Okay, so let's see. For 9 I will split it into 3 parts. Let's call part 1 as P, part 2 as Q, and part 3 as R. This is 3 marbles, this is 3 marbles, and this is 3 marbles. Why 3? We'll come to that in a while, right? Why 3 groups and not 2 groups? Like initially for 3 marbles, we took A, B, and C. We only weighed A and B. The same thing, we are trying to take P as one set, Q as one set, and R as one set. One of the set has only one marble which is heavy, just one of the 3 sets. For now, I'll assume that P will be placed in the left pan and Q will be placed in the right pan. You guys decide. You guys take a second to think. If cases, so case 1, let's assume the left side went down. So part P has a heavier marble. But if part P has a heavier marble, let's say we divide that into 3 parts A, B, C. And for three parts ABC within part B, let's say left went down, right went down. Within that case 1, we'll have three possibilities: left down, right down. The right pan went down. That means Q would have the heaviest set. Again, within Q, we'll have three parts: I, J, K. So left when goes down, right goes down, or equalize. It does not matter. We'll take only one more weighing. And let's say both of them balance. That means your case 3. That means both pan 1 and pan 2, P and Q, the three marbles that you're taken, they balance each other. Still, what's going to happen? Right, we can find out which is heavier, because this, let's say, has three parts, right? Let's say they have the parts X, Y, and Z. Within one weighing, we can identify the heavier marble, right? So all in all, can I do this? Can I summarize the data as a table and say, for we had the question 80 marbles, right? 79 same weight and 1 heavy. So we have marbles, right? And we have weighings. We saw that for one marble, number of weighings is 0. For 2, the number of weighing is 1. But for 3 also, the number of weighing is 1. But from 4 onwards, we were not sure. It could have been 1. It could also be 2. But till 9, it still is 2. And for 10, let's check for 10 what's happening, right? Case 1. Now we're trying to divide it into 3 parts. We really cannot divide 10 into 3 parts. So we could make a 3, 3, and 4. Right? Case 1, let's say, right? Case 1, this side is, the left side is heavy. So yeah, within two cases we can find. Let's say the right side is heavy. Another 2 weighings to be sure. Now that's where the issue starts. It goes into a vicious cycle if we are not sure, right? That means from 10 onwards, to be certain. Question is not to find just the minimum number of weighings. The question is to be certain to know that with 3 power 0 happens to be 1, 3 power 1 happens to be 3, up to 3 squared, that is 9. In fact, up to 3 cube, which is 27, to know the number of weighings, to be sure, will require only 3 weighings. Would you guys like to try for some number like 27? Let's say I have a number like 26 marbles. So what I'll do, I'll take 9 marbles as one set. Let's call it P. I'll take another set as 9 marbles. And the third set, let's call it R, will take 8 marbles. So you understand 3 sets we have. Let's take the set 1 and set 2 and place it in the pans. Right, let me just draw the pans for you. We have this pan balance, right? Let's say I put P here, I put Q here. Now let's say, this pan is heavy. This side is heavy. So for 9, we require another 2 weighings. So one weighing was to identify between P and Q. Another 2 weighing for 9 marbles, we require 2 weighings, right? With that, we can find out in 3 weighings, right? Let's take the extreme case. That means P and Q are eliminated because R has the heavier set. So now we have R, which has 8 marbles. Let's further divide it into 3 parts, right? That is I, part J, and part K. I has 3 marbles, J has 3 marbles, and K has 2 marbles, right? So what I'll do for now is, let me say that I take, let's say that I take, we know this set is heavy. Let's say I take the part, I and place it in this, and J and place it in this, right? Instead of P and Q, between P and Q we have already decided. So between I and J is where the decision should now happen. Between I and J is where the decision starts happening, right? So there could be 3 possibilities. There could be 3 possibilities. 1, I being the heavier side, okay? Then we have identified the heavier set. Already we have done one wing, right? Okay, already, one second here, right? Already we have weighed it once. Next time, between for these 3 marbles, we'll require another wing, right? Plus between I and J, we require one wing, right? But then let's take an extreme case here. Okay, so between the 3 marbles, between the 3 sets, that is P, Q, and R, we identified both are of the same weight, so we eliminated both. R is the heaviest set. We have divided into I, J, K. To identify between this I, J, K, which is heavier, we require one set. Let's say these two equalize each other. So we are left with set number K. Each cross denotes what we are eliminating, right? We have set K, which is 2 marbles, and for 2 marbles, again you have to wait once. Let's call this as marble A and marble B. That's marble A and marble B. You require it once. You notice that it's all following powers of 3. And guys, please understand, this is to be sure. It's not otherwise. It's not that I can randomly say, okay, this is holding true sometimes, not holding true sometimes. It is to be certain what you would do. That means this logic will work for 3 power 4, which is 81. Up till 81, up till this number like 81, you'll require 4 wings. Are we okay with that, right? Are we okay with all the logic that we have done? So let's summarize, okay? If you have marbles and wings for a 2-pan balance, right? With up to 1 marble, you'll require 0 wing. Up to 3 marbles, to be sure, you'll require 1. Up to 9 marbles, to be sure, you require 2. Up to 27, to be sure, you'll require 3. And you'll notice, because 3 power 0 is 1, this and this number is matching. 3 power 1 is equal to 3. The power of 3 and the number of weighings are matching. 3 square is equal to 9. Power of 3 and the weighing is matching. 3 cube is equal to 27. The power of 3 and the weighing is matching. That means 3 power 4, 81 and 4 weighings, and 3 power 5, 243 and 5 weighings, and so on and so forth. Right? All on the same page? Superb. Okay. This is just an extension. Let's understand this to be an extension. Right? This power of 3 is just an extension. But let's build some more logic so that we can answer this question. Let's build some more thought process behind this kind of questions. Right? What thought process are we talking about? Right? Uh, what thought process can we think beyond this? Right? If this question is true. So we will shift this question to a slightly different set. Okay. What we'll do is, instead of taking a 2-pan balance, we'll take a spring balance, right? And slowly I'll start summarizing results on this sheet, right? On this sheet. So for a 2-pan balance, what happened in a 2-pan balance, we can easily see, right? For a 2-pan balance, right? We saw that it's some logic on powers of 3 that is working. We'll take a spring balance. Now you'll notice in a spring balance, normally the weight is denoted. In a 2-pan balance, you'll have to put a weight on one side, right? A spring balance, may look something like this, right? May look something like this. There's a spring, and the spring will pop out, and the spring will give us some number, right? That number will be fixed on some particular, calibration device, right? On some calibration device where it indicates the number, and here they have another pan. They have another pan where they made the weight. So let's, for convenience, let's take the same question or similar question. Let's say there are 60 marbles, and one being heavier. But the remaining 59 marbles are 10 gram each, and this heavier marble is 12 gram. There's only one heavier marble, right? Remaining marbles are all, right? There are 60 marbles. I've changed it from 80. I made it a number like 60. So 60 marbles, one heavier. So let's see how to work with this question. Right? 60 marbles and one being heavier. So what do we do? What do we do with this question? Right? So that's how bad my drawing is. I hope you guys can, you guys are okay to understand the question and not the drawing, right? We'll take a course on that later. So yeah, coming back. So how many times? So if we use the similar algorithm that we did, mathematical induction, for one weighing marbles, for one marble, number of weighings required is 0. We understand that marble is heavy already. For 2 weighings, there could be marble A and marble B. So case 1, if marble A is 12 gram, automatically you know it is heavy, right? If A is 12 gram, right, you already know it is heavy, right? Case 2, if A is 10 gram, you know the other marble is heavy, that means B would be heavy. That means the number of weighings required is only 1, right? But what if instead of 2, we have 3 marbles, right? Instead of 2, we end up having 3 marbles. So we have A, B, and C, and we do not know which marble is heavy. We have absolutely no clarity on which marble being the heavier marble. So we'll see, okay? We'll see what we can do, or what we can pick from here. So one possibility, case one, let's say marble A is 12 gram. So good, you found an answer in one wing, but you're not sure. Case two, let's say A you weighed, you got it as 10 gram. But using that, do you know which is the heavier? No. So whatever you have to do, you have to go to B and find out if B is 10 or 11. If B is 10, good, you know C is heavier, your two weights is required. So among them, you'll always take a bigger value between 1 and 2. Whichever is a bigger value, that will be sure. But what if this was heavy? What if this was heavy? That's fine. It's still two weights. What if B was same 10 gram? Still C is the heavier marble. So for 3, to be sure, you cannot do it in one weighing. It may happen, but it's not necessary. Like I said, it's not always that lucky, right? So to be sure, you require two weighings. In fact, for 4 as well, you require for sure the two weighings. That's the minimum required, right? For sure, to be sure, to be certain about it, right? For 4 also, to be certain about it, you require a total of two wings. Let's see that example for 4 as well. Okay, let's quickly work on that 4. So we have A, B, C, and D. So what will we do? Will you take one marble at a time and do it? Of course not. What we'll do is we'll split. We'll take A and B and check, because each is 10, that should be 20. We'll check if each is 10, that should be 20. But instead of 20, if this becomes 22, right? Let's say this is 20, right? We want to weigh and it's 20. Instead of 20, the set is marked as 22. That means this has the heavier set. Now between A and B, one of them we will pick, and we can quickly find out which is the heavier marble. Okay, fine. All of you, are you on page? Please give a thumb. Please tell okay if you guys are understanding. That's superb. We understood that even for 4, the required number to be sure is only 2. What if I have 5? What if we have 5 marbles? Let's say A, B, C, D, E. 5 marbles. We cannot divide in. You can say, why not divide it into 3 and 2, right? Why not divide it into 3 and 2? What if this becomes 30 and this becomes 20 or 22 or whatever that is, right? Or 32. We cannot be certain about it, right? To be certain about it, you require 3, because you cannot directly say for 3 you will require 1, right? You are going to break it, you're going to further break it, right? Okay, you cannot be certain. So if this part happens to be the heavier part, for 3 you notice that you require, to be certain, you require 2 wings for 3 marbles, right? So that means out of the 5 you've reduced one set, 2 sets you've broken, right? This could be 30 or this could be a 32. If this is a 32, then you'll require 2 more wings, right? So to be certain, for 5, for 6, for 7, even for 8. Let's try that for 8, for a change. 8 is a bigger number in that particular set. So let's try that for 8 marbles, right? Let's see for 8 marbles. So for 8 marbles, what we'll easily do is we'll divide it into 2 parts. Set 1 and set 2. We'll check if this is 40 gram. If this is 40 gram, that means this is the heaviest set. But if this is 42 gram, no worries. This itself is the heaviest set. For a minute, let's assume that set 1. For a minute, let's assume
press the bell icon on the YouTube app and never miss another update.
Let's assume that set 1, for a minute, let's assume that set 1 is 40 gram. So now what we do is we have weighed it already once, right? We weighed it already once. Next. Now we have to concentrate on set 2, because set 2 is definitely 42 gram. You don't have to worry, but we'll have to divide it into 2 parts. We'll take this as part 3 and part 4. We'll try to weigh part 3 and part 4. If part 3 is 20 gram, we are happy to know that part 4 is a heavier marble, so we have weighed it once more. Now we have for sure part 4 will be 22 gram. You don't have to weigh part 4. right? You'll just take one of the marbles, let's call it marble 5 and marble 6, and check which one of the first marble, if that is 10 gram, then the other one has to be 12 gram. But if that is 12 gram, that is a heavier one. That means you require only 3 wings. So by now, most of you have started noticing certain patterns in these questions, right? Example, here you easily would have noticed that this is number 2 power 0, 2 power 1, 2 square, 2 cube. 2 cube is 8, 3 and 3 matching. 2 square is 4 and this matches. 2 power 1 is 2. At the power of 2 and the number of wings matches. That means for 16 we require 4 wings because 2 power 4 is 16. 2 power 5, that is 32. Number of wings required is 5. 2 power 6, that is 64. Number of wings required is 6, and so on and so forth. This process continues, which means 60 marbles is there. To be sure, we need to think on a number like this, right? 6. So we understood the concept of pan balance, we understood the concept of spring balance, right? But you notice that this follows a power of 3 and this follows a power of 2. To explain this better, I'll have to explain the concept of addition versus the concept of addition and subtraction, right? How do I explain that, right? But let's summarize this. For a 2-pan balance, the concept is 3 power n, and the spring balance, the concept is 2 power n. There's only a concept of addition here. There's a concept of addition and subtraction or deletion. So this question, I'll take a question similar to this question on Rohit, but for a minute, let's remove this number as 198 and make it 100, right? Let's make it 100 and we'll do this question later. Okay, we'll do this question 100, and we don't want to carry minimum number of bags. Okay, we'll change the question a little bit, right? The question we will reframe this way, right? We'll reframe the question as this, that what is the minimum number of bags, right? What is the minimum number of bags? Finish. We'll remove this part of the question. What is the minimum number of bags required? So we have a bag 1, right? We have a bag 1, right? This bag 1 is there, and in the bag 1 we can place as many coins that we want, but any denomination, right? Cash of any denomination between 1 and 198 should be allowed for us, right? So what do we do? What do we do, right? So let's take this bag 1, bag 2, bag 3, bag 4, bag 5, bag 6, bag 7, bag 8, bag 9, and several bags. We have to ask ourselves a very elementary question. This is a very thought provoking but elementary question. The first thing that you got to ask yourself, see the question we are doing is slightly different. What is the minimum number of bags? That's all, right? The first thing is that what is the least amount of cash that we need to hand over, that Rohit has to hand over. Least is 1, so we put 1 rupee in this bag, right? We put 1 rupee in the bag. Next, what is the next amount that Rohit can be asked? Rohit can definitely be asked 2 rupees, correct? So 1 rupee is already here. If he's asked 2 rupees, he does not have 2 rupees. There is no use of putting 1 rupee in the next bag. So 1 plus 1 is 2, because you want to decrease the number of bags. You'll put 2 rupee in the next bag. That means 2 coins. Now, the next value they can be asked, 3 rupees. But we already have 3 rupees, right? We have 1 plus 2, that is 3. We don't have to worry about 3. What we got to worry is about 4, because we don't have 4. Now there is 4, and it's easy to observe that 4 plus 1 will give us 5, and 4 plus 2 will give us 6, and 4 plus 2 plus 1 will also give us 7. So we have all the numbers till 7. What is missing for Rohit to identify with is the number 8. So next back, but by now you'll notice that this 2 power 0, 2 power 1, 2 square, 2 cube. In fact, by here you got all numbers from 1 to 15, because 8 plus 4 plus 2 plus 1. How do you make 10? Let's say 8 plus 2. How do you make 11? 8 plus 2 plus 1, how do you make 12? 8 plus 4, how do you make 13? 8 plus 4 plus 1, and so on. How do you make 15? 8 plus 4 plus 2 plus 1, which means any number from 1 to 15 is allowed. What is the next number that we need? That's obviously 16. Finish, and you notice that is power of 2. The next number you need is 32. So 2 power 5, that is 32. By now we have arrived at a number called 63, because 32 plus 16 plus 8 plus 4 plus 2 plus 1. And guys, any amount from 1 to 63 is allowed. You want to try? Let's give it a shot. Let's say we want to place a number like 51. So you can take 32, right, plus 16, that's 48, plus 2 plus 1. That's it. We have a number that is 51. We can easily identify with this number 51. Let's say another case. Let's say we want a total of 39. So how do you place 30? How do you put? So how do you give 39 rupees? So we have 32, right? This is for 51. How do you place? How do you work with 39? For 39, we'll take a 32 plus, right, 4, that is 36, plus 2 plus 1, that's it, 39, right? Now if this logic is true, what should be the number of coins in this bag? Please remember, we have only a total of 100 coins. Can we place 64 in the next bag? No, of course not. We don't have beyond 100. We already are at 63. To make it touch 100, you can maximum put 37 only in the next bag. And you already noticed from 1 to 63, every number is allowed. So we can put 37 plus 1, 37 plus 2, 37 plus 3, 37 plus 4, or till 37 plus 63. That means we will catch any number from 1 to 100, right? So what is the number of bags required? That's 1, 2, 3, 4, 5, 6, and 7. With 7 bags, we found the answer, right? Which simply means we are looking at a number which is less than 2 power 7 but more than 2 power 6, right? The total number, right, that we are working with, 100 is between 2 power 6, 2 power 6 is 64, and 2 power 7. The number 100 is between 2 power 6, which is 64, and between 2 power 7, that is 128. That's why the number of bags required will simply be this number, that is 7. That's it, right? That's how simple it is, right? Okay, so that's essentially what's happening. Okay, but then if this logic is true, let's build this logic on another question, right? It's a similar type where I can explain addition and subtraction to you, right? So I have a vegetable market, right? I have a vegetable market, and I can weigh, you know, in incremental value of only 1 kg, and from 1 kg to 40 kg, 1 to 40 kg, any weight a customer can ask. Any weight from 1 to 40, a customer could come to my shop and ask for incremental value of integral increments. That means 1, 2, 3, 4, any weight a customer can ask from 1 to 40. So what is the minimum number of weighings required to achieve this feat? What is the minimum number of weighings required to achieve this feat from 1 to 40? So let's ask this question. So, and let's also identify that I have a pan balance in the shop. Let's identify with this. I have a pan balance in the shop, right? And the previous question, remember, I had bags. In one bag it was 1, one bag it was 2, one bag it is 4, one bag it is 8, one bag it is 16, one bag it is 32, and the last bag it was 37. So let me keep that also, keep that aside with that one logic, and we'll see. Now, what is the minimum weight a customer can ask us? Obviously 1 kg, right? So we put 1 kg in one pan, we put the weight in one pan, and the rest, the customers, the vegetables, you put it on the other side, you'll easily be able to find out. So whatever the vegetables are, right? So what next can the customer ask? The customer can ask 2 kg. So what do we do? We can place a 2 kg here. That's certain. But would it help? No, because we want to minimize. So what we'll do, we'll instead place a 3 kg. Why 3? Because I can place 3 kg here and 1 kg here. And now you notice you can still add plus 2 kg veggies, and you're done. 3 and 3 balancing each other. That's how the pan balance works. Which means what you could do is you could add as well as subtract weights, but here you can only add the previous question. You can only add the money. You cannot subtract money. But there is an addition and subtraction. But the previous question, it is only addition. That's why it became powers of 2. There's an addition and subtraction. That's why it's becoming the powers of 3. That's a change. Okay, so now good. Okay, that's pretty. I hope that's clear, right? Why it's becoming powers of 3. Are we okay with that? Because there's an addition and subtraction. Both of them, both operations are allowed. There's an addition as well as subtraction, right? Pretty good, huh? Let's see now. Let's see. So you have 1 and you have 3. So you take 3 here and you take 1 here. You're done with 2 kg. How do you make 3 kg? Just take 3 in one pan and you're done 3 kg. How do you do 4? That's easy. 3 plus 1, 4. So everything from 1 to 4 you're done with only 2 weights. What is the next thing a customer can ask? Certainly a customer can ask for 5 kg. But what do you do for 5 kg? You already have a 4 kg and you can subtract. That means you'll put a 9 kg here. If you put a 9 kg load, 9 kg weight, you take 9 kg minus a 4 kg which you already have. You take 9 minus 4, that is 5. But if you subtract 1 from this and you make 9 minus 3, that will become 6. Isn't it cool? Right? You can place a 9 plus 1, right? You can place a 9 plus 1 here, that is 10. 10 minus 3 is still 7. You can take a 9 here and a 1 here and you have 8, right? And you notice how beautifully we are able to progress with all the weights, right? You have a 8, you have a 9 because 9 kg is already there. To make it 10, we can do a 9 plus 1. To make 11, you can put a 9 plus 3 here and a 1 kg here. Are we getting it? That means 9 plus 3 is 12 kg here and 1 kg in the other pan. Finish. That is cool, right? We can also try 13, 12, that is 9 plus 3, and 13, that's automatically 9 plus 1 plus 3. So we have till 13. We have every possibility till 13. What we don't have is 14. If you want 14, 13 plus 14 is 27 kg. If you take 27 minus 13, that means in one pan I put 27 kg, other pan I put 13 kg, plus vegetables worth 14 kg, right? Or weighing 14 kg, and we're done with the deal. That means in the next pan I need to place 27 kg, right? Again, you'll notice these are powers of 3 because why? We've been telling there's an addition as well as subtraction. If there is only addition, it is powers of 2. If there is an addition and subtraction, it becomes a comparison of 3. If it is only addition, it's a comparison of 2. That means the second thing gets compared automatically, right? This logic, probably someone comes up with a question for addition, subtraction, and some third operation. I'm not sure which operation it could be, right? Then it could become powers of 4 or powers of 5 or any power that we are discussing, right? So if we are clear with this, we can quickly run down to these two questions and we can come back to the teaser question that we left, the first question of the sheet. Let's work on that, right? So Rohit has 198 coins of 1 rupee. He puts it in different bags so that he can hand over the cash of any denomination required between 1 to 198 rupees. He wants to carry minimum number of bags. What is the highest number of coins in a bag? So the first bag, obviously he'll put 1. The second bag he'll put 2. Third bag he'll put 4 because it's just addition, right? Fourth bag 8. Fifth bag 16. Sixth bag 32. Seventh bag 63. Now hold on. If you add till now, that is 7 bags, you'll get 127. 1 plus 2 plus 4 plus 8 plus 16 plus 32. That happens to be 127. But the total number of coins that Rohit has is only 198. He wouldn't dare to put a, you know, a coin with a bag with 128 coins. Instead, he will place the remaining, that is 198 minus 127. That will give us one that will give us 71 coins in the last bag, right? So that will be the highest number of coins, and it will not be the number 128, it will be 71. And of course, it will not be 198, that is out of context. With 198, you don't even do a question like that. It is not necessary that from 1 rupee to 198 rupee, everything is possible there, right? So that's out of context. So this has to be 71. Are we okay with this logic, right? If you're fine, let's go to the next question, and you'll understand pretty much the same thing what we had done. A, B, C, D, E are five distinct weights in ascending order such that any weight from 1 to 121, both inclusive can be measured using a pan balance. So take about a couple of a few seconds here and there, 10-15 seconds. You tell me the answer. What do you think the weight of A, B, C, D, and E are? Right? What's the value of A, B, C, D, and E? Okay, cool. We are done. So since A is the least weight, and we know A is less than B and B is less than C and C is less than D and D is less than E. Why? This is their ascending order. That means A being the smallest. So A has to be 1 like we did previously. There's an addition and subtraction possible. We'll take B as 3, C as 9, D as 27 and E as 81. That's pretty simple. Now we'll add, subtract and calculate the answer. So pretty simple. If you add all of it, you will get the total as 61. That is 1 minus 3, which is minus 2. Minus 2 plus 9, that's equal to 7. 7 minus 27, that's equal to minus 20 plus 81, that is 61. That's a pretty simple calculation here. Now, why we are treating this question this way? Why can't we, why give all this logic to just do a simple question, here, that is dividing the rings, breaking it into parts. Now that's what we were trying to build. We're trying to build the question, the thought process behind this question. So let's come back to the question. And here, now you might be wondering, what powers are we going to use? Powers of 2, powers of 3, powers of 4, powers of 5. The question is slightly different. Let's understand. Let's ask yourself with mathematical induction, if there is only one ring, how many times you need a cut? You don't need a cut, right? If there are two rings, how many cuts do you need? You will cut this ring here, let's say, and this ring is available for you, and this other ring is available for you. You will get a cut ring. With one cut, you can give any number of ring, either one or two, right? Are we okay? One or both of them. If there are three rings, what can we do? We can cut either here or in the center, and we'll have one separate ring which is cut and two joint rings. So you can give, still with one cut, you're able to give one ring, you're able to give two, or you're able to give all three. What if there are four rings? Now what? Now this is where the question becomes a little cheesy. What if I cut somewhere right here? So I have two rings, I have one cut ring, and I have one ring which is intact. Right? We have made only one cut, guys. We have made one cut, right? So we can give 1, we can give 1 plus 1, 2, we can give 2 plus 1, 3, we can give 2 plus 1 plus 1, that is 4. In fact, it is still 1. The question is not the powers of 2 and powers of 3. The question is, what do you need next, right, to make this happen? If there are 5 rings, same way I'll make a cut here. So we have 2 separate, and 1 separate. Now this makes it still possible to give all 5, any number from 1 to 5, 1. 2 plus 1, we can give 3, we can give 2, we can give 2 plus 2, 4, we can give 5. Every number is possible. In fact, even if you check for 6, you cut it somewhere here. So we have 3 rings, right? 3 rings as a loop, as a linear chain. Another 2 rings as a linear chain. And third one is separate, right? We can produce 1, we can produce 2, we can produce 3. This is 1, this is 2, that is 3. We can produce 3 plus 1, that is 4. We can produce 3 plus 2, that is 5. And finally, we can produce 3 plus 2 plus 1, that is 6. So all numbers are possible. What if I have 7? And I think with 7, we'll get to the solution right away, right? If we have 7, right, and that's the intriguing part here. If we have 7, let's say we cut it here. So we have 1, 2, 3, right? We have 1, 2, 3, 4. We have 1, 2, right? And we have the separate one, right? This is where the cut was, right? This is where this cut was that we are trying to identify with, right? So we had 7 rings, and we cut it somewhere here. We cut it somewhere here, and this is the cut piece, right? So we can give 1, we can give 2, we can give 2 plus 1, that is 3. We can give 4, 4 plus 1, 5, 4 plus 2, 6, and 4 plus 2 plus 1, 7. So all numbers are possible. But let's do one thing. Let's try it for 8. With 8, is it possible? Let's make a cut somewhere in between. So probably you can make 1, 2, 3, 4, 5, 6, 7, 8 ring. Where do you want to place a cut? Obviously not at the first ring, somewhere in middle. Let's say we made the cut here, or we made the cut here. That means we have 3 rings here. We have 1 separate ring, and we have 4 rings here, right? Or we made the cut at the third ring. We have 2 separate rings here, 1 cut ring, and we have 5 rings as a loop. Here you'll notice we can make 1. We cannot make 2. We can definitely make 3, 4, 5, 6, 7. We cannot make 6 again, right? That's not allowed, but we can make 3, we can make 4, we can make 5, we can make 7, and we can make 8. Here there's another problem. We can make 1, we can make 2, we can make 3. We cannot make 4. We can, however, make 5, we can make 6, we can make 7. So not all is allowed. That means the moment we have 8 rings in context, you require minimum 2 cuts. So the question, anyway, we cannot continue doing this forever, right? We have 23 rings. We have 23 rings. Let me just number them quickly. Let me just number them right quickly. 17, 18, 19, 20, 21, 22, 23. So that is 23rd ring. So we are sure the number of cuts is greater than 1. It could be 2, it could be 3, it could be 4, it could be any number, but we know it's a number greater than 1. So if you are sure that there will be 2 rings because it's a number greater than 1, that means we need to have at least 2 rings out, right, from somewhere. That means we will get 1, 1 plus 1, 2. So if we make a cut here, what will happen? If we make a cut here, if we make a cut at after the third ring, that means at the fourth ring, if we make a cut, at the fourth ring, I'm taking up this ring, okay? If we make a cut at the end of the fourth ring, so we have what? We have 1, 2, 3 as a loop, plus we have 1, plus we have 1. That means we can put any number from 1 to 5. What's the problem? The problem is we don't have 6. That means from here, if we start 1, 2, 3, 4, 5, 6, if we move here and make a cut after 6, right? After 6 rings, if we make a cut, that means at the 11th ring, if we make a cut. So this is the cut at the 4th ring. We need another cut at the 11th ring, right? If we make a cut at the 11th ring, what's going to happen? If we make a cut at the 11th ring, let's do that. Let's make a cut at the 11th ring, right? So what do we have? We produce a loop of 6 rings, right? You see what's happening. The beauty here, you wanted to have 6, so you made a 6, like the previous question, right? We wanted to give somebody 2 rupees, or we wanted a weight like 5 kg. So what did you do? You did 9 minus 4, and this is more intriguing, but it's not just addition and subtraction, it is beyond it, right? So at the fourth ring you made a cut, at the 11th ring you made a cut. So now you have 3 plus 1 plus 1, that's 5. We found every number. We have 6, and 6, 1 to 5, we have every number we could do, right? So we have 6 plus 5 till 11, we have every number. What is the next thing we don't have? We don't have 12. The rest of the 12 rings can come here. It's damn simple. Rest of the 12 rings here. So we have a set of 12 rings here. We have a single ring here. We have 6 rings here. We have 1 ring here, and we have 3 rings here. What is the number of cuts we did? We did only two cuts, 1 and 1. And you see, every number is possible. Now, someone might ask how to make 19, right? Simple. 12 plus 6 plus 1. How to make 21? Again, simple. 12 plus 6 plus 3, that's 21. How to make 15, right? That's okay. 12 plus 3. How to make 17, right? That's 12 plus 3 plus 1 plus 1, right? That is 17. 12 plus 3 plus 1 plus 1. In fact, every number is now allowed, right? So the thought process is, guys, is this a cat level question? Bet you it is higher than cat level question. But the question is, are we thinking? Are we thinking at that level? If you can start thinking at this level, forget LRDI, right? That is a small task. This is all bringing you to think cognitively. This is all making you to think laterally. This is all making you, to think analytically. And CAT is just an exam. I know it's tough. I know you want to crack it, right? But trust me, here, what we are trying to build is a person who can think in such a way that you become the best product developers in the world. You become the best strategic consultant in the world. You become something which a company looks to. You can be a person who can probably work to revolutionize the way you're already thinking, right? That's essentially what we want you to achieve in life. That means think logically and make yourself to help the entire setup of wherever you're working, right? That's exactly how you should start thinking from here. And I'm sure you guys are with me. So we'll move to another set of questions, right? That took a lot of time, I know, but I hope this is drilled down, because I'm not going to take this logic too many times again, right? Wanted to build a process. You'd have noticed we have done 5 preliminary things before starting of this question, right?
You can learn any subject, anywhere, any place, and on the go. Come, let us go the other way in learning. Download our revolutionary app for free AMC.